everyone. I hope you're doing good right now. This is lesson 2 of cubic functions. Um, this is actually good for all functions, though, to find out if a function is even, odd, or neither. Um, so there's a test to find out if it's even, odd, or neither. Um, Basically, you need to take the original function. So here's an example. And you're going to plug in a negative x wherever you see x and then simplify it. The rules indicate if all the signs stayed the same. So if you end up with like the original function after you did this, then you're going to have an even function. Um, One of the things about even functions is it's symmetric about the y-axis. So sometimes you can also determine that it's going to be an even function by just seeing the graph. Um, if it's an odd function, so if we plug in the negative x into the equation, if it's an odd function, all the signs are going to switch to opposite. So if it was a negative in the original, it's now going to be a positive. If it was a positive, it's going to be a negative. But it has to be everything that switches. If only pieces of it switch, then it's neither. It's not an odd, an even, it's neither of them. Okay. Usually for an odd function, our key thing to look for is that we're going to have symmetry about the origin. So we're going to be able to see symmetry in the graph on the origin. So again, if you're looking at a graph, you can sometimes see that also. So let's do an example. Actually, 2 examples. So the first example we're going to do is negative 3x squared plus 4. So what we're going to do is instead of x here, we're going to plug in negative x. Okay. So we're going to have negative 3 still, and then parentheses negative x squared, and then we still have the plus 4. So we're going to do parentheses first, which is our exponent. So we get a negative x times a negative x. That gives me a positive x, right? So simplifying it, you'll see that negative 3x squared plus 4. So when I plugged in a negative x, I ended up with the same equation as the original. So with a squared, that's going to happen. And because quadratics are usually symmetrical about the y-axis, that's why we're seeing this. So because we got the original, we can say that this function is even. Okay? So let's try another one. So this one is 2x cubed minus 4. So everywhere where we see x, we're going to plug in a negative x. Okay? And so what happens here is we get negative x times negative x, which is a positive x, but then times another negative x. So in this case, I'm now going to have a negative x cubed. Okay? Okay. So now because of that, we're going to simplify this. And so when we put in when we put this in, we're going to get 2 times that negative x cubed. So it's a negative 2x cubed. And then we still have the negative 4. Now, if we look back at the original, we'll see that this one changed signs, but this one stayed the same. So because only one of them changed signs, it didn't stay the same and not everything switched. So this function is neither. Okay. So let's try one where we get an odd function. So I'm going to erase this so that we have room to do one more. So the last one's going to be very similar. I'm going to do I'm going to do one that's similar to the last problem. So it's going to be negative, it's going to be 2x cubed again. And then I'm going to have a minus 4x. So in this case, the problem's a little different because we have an x now. So you're going to see what happens. So to test it, we're going to plug in a negative x everywhere where I see x. So I'm going to have 2 parentheses negative x minus 4 parentheses negative x. So from the previous problem, we learned that negative x times negative x is a positive x times another negative x is another negative x. So we're going to have 2 times negative x cubed. When we do that, it's just a negative 2x cubed. And then here we have a negative 4 times a negative x. Well, a negative times a negative will give me a positive 4x. So if we look at the original, this used to be positive, now it's negative. This used to be negative, and now it's positive. So because every sign switched, we know that this function is odd. So we did one of each, okay? If you have any questions, feel free to message me. Again, this goes with lesson 2's assignment. All right, bye.